Okay, this problem says two monoatomic ideal gases A and B are at the same temperature. So if they're at the same temperature, that means the kinetic energy per molecule is the same. Okay. If 1 gram of gas A has the same internal energy as 0.1 gram of gas B, what are the ratio of the number of moles of each gas and the ratio of the atomic masses of the two gases? Okay, so energy is the same, and okay, okay, and at the same temperature, Ta equal to Tb implies 1/2 okay. So since this implies that, by the way, this is a monoatomic ideal gas. So monoatomic ideal gas, they only have kinetic energy. So EA the total energy is the number of molecules times the average kinetic energy per molecule. But since this was equal to that, okay, that implies that you have the same number of molecules. Now, what they tell you is has 1 gram of A is 0.1 gram of B. So that tells you each molecule, since they have the same number of mass, same number of molecules, A must weigh 10 times B. Okay. Mass of A, number of A times mass of each molecule. Okay. So 1 gram divided by 0.1 gram. So the ratio of the masses is 10. Atom A is 10 times heavier than atom B. That's what we found. Okay. The ratio of the number of moles of each gas and the ratio of atomic masses. So this is part B actually, and we'll part A is, since Na by Nb, number of molecules is the same, the ratio of the number of molecules is this atoms is the same as the ratio of number of moles, and that's 1. Okay. Everybody understand this? Number of atoms is proportional to the number of moles. Okay. Okay. I'm sorry? The number of atoms is the number of moles times Avogadro's number. If this is the same, Avogadro's number is the same. Okay. So number of A atoms is number of moles of A atoms times Avogadro's number. Number of B atoms is number of moles of B times Avogadro's number. And since Na by Nb Avogadro number, that cancels, and that's equal to 1. Okay. All right, that solves that problem. So let's. The moles is just the count, how many there are. So if you have this, okay, so if you have the same number of atoms and this weighs 100 times than this, then each atom must weigh 100 times. Okay.